think we can go ahead and get started, and as people come in, we'll just keep going through it. So my name is Jess Jowdy. I'm a sales engineer at InterSystems. I work primarily in end-user healthcare. They told me to press the red button. I already had forgotten that. I will be talking to you today about DeepSee measures, specifically answering the question, can it be measured? The answer is yes, but that's the short answer. We're going to get into a little bit of the long answer of that. So how many of you here have at least worked with DeepSee in the past? Is it completely new for anybody? Okay, great. All right. So let's see if I can move this. Great. So DeepSee is the analytics platform that InterSystems has. What we can do is really leverage Cache as a massively scalable database and run analytics on a large amount of data. I like to think of DeepSee as being able to put large amounts of records into buckets. Now, what buckets are these records going into? Well, that's really up to you to define. And I believe that there was an architect data structure session on that, so you can go back and look at that. But really, if we're thinking of a data set, in this case, we're thinking of a data set of sales transactions. So how many units have been sold, how much revenue was generated because of that sale. What kind of buckets am I interested in putting data into? So in this example, I'm looking at a pivot table. I'm interested in, say, what region were those transactions occurring in, or what product was sold as a result of that transaction. Those are different buckets that I can put data into. Now, in the middle here are all of the records. Oh, and sorry, I'll say one other thing. So I have a bucket for a region that a transaction happened in. I have buckets for what product is being sold. But maybe I want to filter that data down. Maybe I only want to look at, say, products or transactions that happened online. We can apply filters to that data, so we only have a very specific set of records we're looking at. And once we have that set, that union of all of these different buckets, what we can do is run measures on that. So for example, if I added up all of the revenue that I generated across all of the records in that bucket, what would I get? Or, using that same record set, how does that compare with my competition's revenue? So using the same record set, we can run many different types of measures, calculations based on the information that you need. And that's really what the heart of this presentation is. So let's get to that agenda. So what we're going to be talking about today, really the importance of measures in DeepSee. Why do we actually want to calculate anything? What's the importance of that? Oops, sorry about that. We're also going to talk about 4 different types of measures. Standard measures, calculated measures, quality measures, and plugins. Each has a little bit of a different spin on how to do measures. Each is important for its own purpose. We'll go over why you might want to use each one of these different types. And then we'll go over some next steps if you want to get additional information about any of these topics. So let's first talk about the importance of measures. So you have now successfully gathered all of this important data from a variety of different data sources. You've brought it all together. Now what? You have all of this data. What do you do with it? And I believe that data is really only powerful when it's actually being used. Otherwise, it's just taking up space. You want to do something, make an action on something because of this data. So maybe maybe you want to make a change in your application or cater to a different population for, say, these transactions. Maybe there's a whole different market that you've missed. Really the point of having measures is to have a tool to be able to explore patterns in data so we can actually act on the data that we have. Otherwise, it's just taking up space. So DeepSee, as I said, its extensive analytics framework can really leverage Cache as this massively scalable database to capture and analyze large amounts of data. So that's really the importance of measures. So quick basics on DeepSee. We really have 3 portals that we use in DeepSee. We have the architect, the analyzer, and the user portal. So the architect is where you're going to define your cube data structure. So we have a cube data structure, which is a little bit different from a table. A table, you have your fields, you have your rows, and each row has a value with that field. With a cube, we have more of a hierarchical structure. We have a dimensions, hierarchies, levels, and members. So it's this multi-dimensional structure that we use. We can also define measures within architect, which we'll go into. And then because this is a cube and not a table, we're going to be using MDX, not SQL, to be able to query this. So MDX is the querying language for cubes. Then we have Analyzer. Analyzer is the portal where you can slice and dice data. So we're going to use some of the measures we defined. We might want to define additional measures in Analyzer, but we're really looking for trends based on different contexts. And contexts are the intersection of all those different buckets. We really want to determine relationships between data elements. We want to look for those patterns. And once we do find those patterns, we're going to define pivot tables that we can use as the source of widgets for our dashboards that we display to users. Which brings us to our third portal, our user portal. This is where users can come in and see dashboards that display widgets that are graphical representations of the data patterns that we saw in Analyzer. So those are really our three big portals we use, each very important in DeepSee for different reasons. So for the purposes of this presentation, we will be working with the Whole Foods data set. So Whole Foods has a couple of tables within your samples namespace, if you're familiar with that. So you can go and look at this table if you want to, or you can look at it, after this session. But it includes fields for those sales transactions. So it has information about what product was sold, the date it was sold, where it was sold, how much was sold, any discounts applied to it. So this is really what we'll be using for our measures for the rest of the session. So without further ado, let's start talking about some measures. So the first measure we're going to talk about are standard measures. Now the big thing about standard measures is that they represent a value for each record in the source table. So that means that each record in the source table has with it a distinct standard measure, or not a distinct, but its own standard measure that was computed during the build cube or the build sync. So really when you're defining a standard measure, the question you want to ask is, what exactly do I need to measure? Does this value already exist in my source table, or do I have to do something to get a value that I need for my measure? So in the first case, let's say this value exists in your source table. You just got to pull it out and do some kind of aggregation on it. We can specify a source value to be just a class property from your original source table. And so we're just going to really just go into that source table, pull out that value, and stick it in our measure. But let's say we have an instance where maybe a value that we need from our source table isn't discretized. It's not something that we can actually, aggregate on. We might need to do some additional computation or some additional work to make it a discrete value. We can also specify our source value to be some valid cache object script expression that can then manipulate that data, and then we can perform an aggregation option. So what kind of aggregation options do we have for standard measures? Multiple. We have a ton, but typically we see sum, min, max, count. We can define these to aggregate the source value that we've defined above. Now, standard measures can be defined as searchable, which is very cool if you're using them in a pivot table. So you can actually use standard measures as filters. And the other thing is there's a ton of different settings that you can pick for standard measures, one of which is changing the display format. So maybe you want to add dollar signs or percents, depending on what the format is. Maybe you want to change the color based on whether it's a positive or negative value. You have a lot of different options for that. So let's take a look at what this actually means in a real situation. So our Whole Foods data, if we recall, is all the sales transactions. And we're interested in knowing the amount sold based on a particular record, and also whether that record is considered a big sale. I'm defining big sale as having at least more than five units sold in that transaction. So let's think about this first situation. I want to know the amount sold per record. Now, this property actually exists right now in our source table. It's called amount of sale. You can fact check me when you look at the table in the samples namespace, but amount of sale is the property that exists in this table. So we don't really have to do any additional manipulation. We just need to define an aggregation in order to bring all that data together. So we're going to pull out the amount of sale value from that field in the source table. We're going to aggregate it via sum, and we're going to format it so that it looks like it has that dollar, it has the cents. We format it to look like it was a monetary value. Let's contrast that with this big sale count. Now, we don't actually have a field in the Whole Foods data set that says whether or not this is a big sale. There's no Boolean value. That's something we need to construct ourselves. Now, how would we do that? So here we can, instead of specifying a property, because we don't have that property, let's make that property. So we define a valid object script expression to say, okay, let's make this value a 1, so yes, if the units sold, which is one of the fields that we have in our source data set, if the units sold is greater than 5, let's make this value 1, otherwise let's make it 0. So in this case, we might not actually have the value, but we're able to get the value based on what we have. And then let's aggregate that by counting them. So we see there are two different methods of doing a standard measure. We can also notice here that our display name differs from our name of the measure. We can display things to have different names just so that they're more human readable. But we do have a lot of versatility in what we want to measure. All right, calculated measures. So I think the best way to define calculated measures is to say how they differ from standard measures. So let's recap on standard measures. Standard measures, there's a value associated for each record. We're either using object script or we're pulling from the actual source table to grab a value. We're calculating a value for each record at the cube build or at the cube sync. So in our fact table, there's going to be a measure column, and each record is going to have a value in that column associated with that standard measure. And we're aggregating them using bit indices. So what's the difference between calculated measures? So what a calculated measure does is, instead of having it be associated with one record, it really spans an entire record set, or an entire bucket, if you will. So it's based on the cube definition rather than the source table. So we're pulling data from the fact table, we're pulling it from the cube that was generated, not from the original source table. So because of that, we have to use MDX, because we're querying a cube, not a SQL table. And these are calculated at runtime because we don't actually know what bucket you're making, right? So what we want to do is say, okay, depending on what's in context, let's make this measure work. Let's calculate this measure based on what we're actually looking at. And this is aggregated using bit-mapped indices. So let's actually see an example of this to put this into context, no pun intended. But so here's 5 different types of calculated measures. We have measures based on other measures. And I was told this is a little bit hard to see, so I apologize. But the slides are available too on your app if you want to see. So there is measures based on other measures. So maybe I want to define a calculated measure that's based on 2 other measures that I've already defined. For example, we just did this measure. We just made amount sold. But maybe I want to know how much revenue I am generating per unit sold. Unit sold is another measure, another standard measure that I made. Amount sold is standard measure. I really want amount sold divided by units sold. That's dependent on 2 different measures. That's a calculated measure, a form of a calculated measure. I can also do calculated measures based on a percentage of aggregate value. So maybe I want to know how many of my transactions are actually considered big sales. Maybe I want a distinct member count. How many different types of products am I selling? How many different regions or different locations am I selling into? Semi-additive measures are kind of interesting. In this example, I think the easiest way to think of these is an example, but Consider, for example, a balance in a bank. So you don't necessarily want to add your balances across time, right? Because your balance isn't, subject to the day, the day before, the day before. Adding them together doesn't make any sense. You really just want to look at the last one and then, add or subtract the values from that current day's revenue. So that's what semi-additive measures really do. And then filtered measures, maybe you only want to apply a measure to a particular subset of your records. So maybe I want to find the max units, but only for products that were sold in Asia. So we can apply filters to our measures prior to the measure actually happening. So how do we define calculated measures? There's really two different locations to define them in. You can define them in Architect, so when you do the cube definition, and you can also do it in Analyzer. When you do it in Analyzer, you have the option to save it either locally, which saves it as part of the pivot table, but only to be used as that pivot in that pivot table, or you can define it to be shared, so it's available to any pivot table that shares the same cube definition. Now, really, you might want to be asking, okay, why do we have two different places that we would define this? But it's really important when we think of Cache's role in resource-based security model. If you're an application provider and you've developed this cube definition and you gave it to an end user, and that end user wants to make their own calculated measure, do you want them being able to go in and access the entire cube definition and possibly, ruining or changing something that was vital to that definition? Probably not. So what you can do is have this distinction between where you can define a calculated measure and where you can define the cube definition. Also, as I said, this requires a valid MDX expression. I don't know how familiar you are with MDX language, but we do have an expression builder that allows you to drag and drop different dimensions and members into a box that will automatically make the syntax for you. So I think that's a really great tool. So let's look at an example of a calculated measure. I want to know the amount of growth that Whole Foods has experienced over the last 5 years. This is dependent on the current year, 5 years ago, and then the difference between the two, and then let's assume that we had that same revenue at that current year propagated across 5 years. So right now we see that this calculated measure is dependent on values that were determined after the cube build. So we see we're doing valid MDX expressions to be able to grab those values, manipulate them a little bit, and then produce a value for the actual growth given as a percentage. And once again, we have a name and a display name if we wanted to change that. Now, why do I have two different pictures here? So this was defined in Architect, this was defined in Analyzer. We can see they both provide the same prompts for you to fill in, except for, one is defined during the cube definition, one is defined on the pivot table. Both execute at runtime. And then this little magnifying glass here that allows you to open the expression builder that will start automatically generating some of that syntax for your MDX expressions. All right. Quality measures. So I'm probably going to spend the least amount of time on quality measures because quality measures are really calculated measures that are a little bit more formalized. And what do we mean by formal? Really, what quality measures do is they're able to apply a hierarchy to your measures. So it's really like putting them in folders or directories, which are called sets and catalogs. So if you wanted to group your measures based on a particular application or a particular data set that you're looking at, or whatever organization you want, you can do that with quality measures. But really what quality measures are calculated measures. They both are defined by a formula that uses an MDX expression. They're both calculated at runtime, both looking at the cube. So quality measures are actually usually defined as a percentage. So really it's how well is your organization operating with respect to some type of standard, some standard. So for example, if you're a hospital, you might be asking, okay, what percentage of my patients have been readmitted in the last 30 days? That might be the standard you're looking at. but it's really based on what your organization is interested in. And this is one of those instances where having this measure could actually produce actionable change, right? So if you have this value, you can actually make changes in how your system's operating if that presents itself. So how do we define quality measures? Well, really quality measures are a bunch of buckets, a bunch of different groups. So you define a group as some grouping or set of records. In this case, my set is the current product that's in context in my pivot table. I also have a second group that's pulling all of the records. And then once you have your groups, what you do is define some kind of operation to link the two. In this case, I'm dividing my first group from my second group. And that's what gives me my quality measure. So you can see these are all percentages here. They add up to be 100. And what I'm doing here is just seeing what percentage of my transactions are for candy, are for cereal, et cetera, et cetera. Not a very interesting quality measure, but I think it shows exactly how this works and how it could be used. So this is what I think is the coolest part, plugins. I really like plugins, so I'm going to spend a little bit more time on this compared to the others. But before we get there, let's talk about what functionality do we have so far. So we know that all of the measures in a pivot table represent some kind of aggregation of the data in a particular result set. And that result set's based on whatever the context is. With standard measures, DeepSee does the work for you by aggregating the values based on a specific aggregation function. Each record has that value as a result. So each record has associated with it a standard measure that DeepSee has calculated for you. With calculated measures and quality measures, DeepSee is still doing the work for you because it's actually running a defined MDX query on a set of records that's in a context, and it's providing you with a result. So really, in both instances, DeepSee is doing a lot of the heavy lifting. But what if you actually need complete control over how to calculate a measure for a result set? That's where plugins come in. So plugins are the ultimate custom measure. So really what it allows you to do is take complete control over your record set. So you can perform a custom calculation on a set of records, or you can even have access to the lowest level of data. So not only do plugins provide you with the actual context of the record, so what row, what column, what filters are being applied, but it gives you access to the actual records themselves in the result set. So using a documented API, you can loop through those records, you can perform some kind of action on those records, some kind of calculation, and then send that result of that calculation back to the calling pivot table that called the plugin. So how do we define plugins? Plugins inherit from this %deepsee.plugin class. They include an X data block called KPI because they're a type of KPI. But there's a lot of different parameters that you can set in this class definition. I didn't list them all. I list a couple that I thought were pretty interesting. The base cube parameter specifies which cube is being used in the plugin. You can set this to be the asterisk to be used by multiple cubes. So if you wanted to make this a dynamic parameter, so you can incorporate multiple different types of cube definitions. The listing source is asking, okay, where am I pulling my data? Where's my record set residing? Do I have to go all the way back to the source table to grab all of my data? Or can I go to the fact table? So are we querying our original source table, or are we using the cube definition? So we do have that option. So this KPI data block, really the big thing with the data block is it requires having at least one what we call property specified. The property is the measure that you're calculating. It's just the name for the measure. And what we end up doing is setting that property equal to the value we've ended up calculating, and I'll show you how to do that in a second. But we can also include in the KPI data block filter tags, and what filter tags allow us to do is pass in values for particular dynamic properties. For example, this %cube filter, maybe I want to be able to use this plugin for different types of cube definitions. This %cube filter will let me pass in whatever cube I want to. Same with the percent measure filter. Maybe I want to make this available to different types of measures. Maybe I want to grab data for the amount sold measure and the big sale count. I have that option to specify whatever measure I want to in there. So here's an example of a KPI data block. We have the KPI tag here where we specify the name of the plugin, or the plugin class, and then we have the actual name of the plugin and then a caption for it. I could have come up with a better caption than that. But then in here we can specify our filters. So we're expecting, say, a cube name passed as a parameter. We might also be expecting a measure to be passed in as a parameter as well. And then this is the most important part here, besides this KPI part, the only part you really need to specify, which is the property. So what measure am I actually measuring? I've called this CompDiff because we're going to be measuring the difference between Whole Foods' revenue and their leading competitors' revenue. So we talked about that there is this documented API for both accessing the records in a result set as well as the context of that result set. That's known as the %onCompute method. So what you can do in the %onCompute method is you can iterate through all of the facts, all of the records in your record set. You can do some kind of calculation, you determine the value of your measure, and you stick that measure back into the property and send that back. So at a minimum, there's a series of properties that need to be returned back. I'm not going to go through all of these, but I will highlight this bottom part, this %data. So this is where we specify that property from our KPI data block, which is CompDiff. And we set this equal to the value that we've gotten from our measure. So I know that's kind of abstract, so let's put that into perspective really quick. This is an example of what we're going to see in a second. So being able to get a difference between the total revenue from Whole Foods and the total revenue from our competitor. And so what we're going to do is we get our result set. Our result set gave us back the amount sold, right, and what we want for each record. And what we need to do is add up all of our amounts sold to get our total revenue, right? So that's what this while loop is doing. We're going to take every record, we're going to pull out that amount sold value, we're going to add it together, and we're going to get our total revenue. And then we're going to return back to our pivot table that called this our total revenue minus this get competitor data that I've made a method, and we'll talk about what's actually happening in that method. But we see a couple of other sets we need to do, but this is really the big important one right there. So the other thing that's pretty important about this is that because plugins are completely customizable, the plugin has no knowledge of what kind of computation you're going to be doing. So computations can be much more expensive than a standard measure or calculated measure. They could rely on outside data sources. So maybe you're making a web service call, and let's say that web service is down, or it's overloaded and you're not getting a response back. We don't want to hold up the other measures from executing, right? Because each one of these cells is calling out to that plugin, because each of these is a different bucket that needs a value. So plugins are called asynchronously for each set of records. So each one of these cells makes an asynchronous call. And what they do is they display this percentage complete to show you exactly how far along they are in that computation. This is optional. Within your plugin, you can specify what percentage complete everything is. But the idea is because we don't know what you're doing, we don't want to hold up the rest of the records from executing. So let's talk about this example. In this example here, we want to retrieve data about our competitor. That data actually is not natively residing within our source table, but it is accessible via a REST call. So what we need to do is call out to the RESTful service using a GET request. That GET request will have two URL parameters, the product and the region. It's going to return back a JSON payload that contains the competitor revenue information for that particular context that it's operating in. And then our plugin's going to parse that JSON and make it available to our pivot table that called in. So for the purposes of this demonstration, the RESTful calls all pass through Ensemble. Obviously, that doesn't need to happen. I just really like working with Ensemble. I think it's great because it provides a testing framework for connecting to the web service, and it gives you visibility on your requests and your response messages coming in and out. But obviously, you didn't have to do that. So if we're looking at how to define this plugin, so this is happening. So right now we can see this is in the architect, and we notice up here that this looks exactly like how we define a calculated measure. Well, this is kind of a version of a calculated measure because what's the definition of a calculated measure? It's based on a set of records, right? And it uses a valid MDX expression to be able to manipulate those. This %KPI method that we're going to be using is a valid MDX expression. So really, a plugin is just a special type of calculated measure. Within this call, we have a series of different parameters that we're passing in. This first one indicates what the name of our plugin is. The second one indicates what the property is that we're grabbing from. So in this case, it was that CompDiff that we defined in the KPI Data Block. This one is the series number. This one is the series number. We specify, or we suggest that should be a 1. And then after that, these are all of the optional parameters that we can pass into the plugin. So for example, I wanted to make the measure, the % measure, a dynamic dynamic parameter to send in. So I specify for the % measure filter on my KPI data block, I'm going to send in the amount sold. I want you to go look at the amount sold measure. So what that allows us to do is vary what measure we're actually looking at. So if we wanted to reuse this for some other type of measure, we can. And then the last parameter here is the % context. That's what gives us the row, the filter, the column. This is going to send all 3 through, but you can choose to send in only the row, only the column, only the filter, or some kind of combination of all 3. So, which brings us to the question, yes, it can be measured. So let's look back at our pivot table from earlier in this session. So we see here we have our region on our columns, we have our product type on our row, we have our region on our rows, we have our product on our columns, and we have 2 different measures on each of these different buckets. These records are experiencing 2 different types of measures. This revenue is a standard measure. We did the calculation for that. That was a standard measure. That data was being pulled directly from the source table. It was the amount of sale that was in the Whole Foods data set. We just added them together. This competition difference, this is that plugin. Where we're calling out via a RESTful or making a RESTful call out to a web service to actually determine what is the value, the revenue that the competitor has given this context. And so we are able to put these 2 measures side by side and really paint a picture on it as far as how well is Whole Foods operating. We've also looked a little bit at some standard measures and some quality measures. So units sold was another one we alluded to. So how many units were sold per transaction? That's another value that we pulled directly from the source table. We looked at product percentage of total. So what percentage of the products are candy? What percentage are cereal, dairy, fruit, pasta, et cetera, et cetera. But what we really see here is there's a lot of versatility in what kind of measures we can do. Depending on what your use case is, if that data already exists, do you need to make that data? Do you need to call out outside of cache for that data? What you choose to do and how you choose to do it really depends on what you need to accomplish. So as far as next steps here, Where do you go next for some of this information? Well, I would suggest going to learning.intersystems.com for some DeepSee instructional material. There's a Learn DeepSee resource guide, which brings you through all of the different paths and material that Learning Services has made for DeepSee. There's also a DeepSee Fundamentals classroom training session that you can attend. There's also extensive documentation on how to do all of this. You can also visit developer community for some examples of what other customers are doing. You can also contact your sales engineer if you do have a use case and you want to architect it out with them. So just make sure to complete the survey in the event app. The sessions recording and slides will be available on the learning.intersystems.com website. And because the tech exchange ends in about 10 minutes, I hope you enjoyed visiting that. So thank you. And if anyone has any questions. Oh, and if you could just use the mic because it's being recorded. I'm sorry. Thank you. Is it enabled by default for Health Insight? Okay. So Health Insights is kind of it's related but a separate beast, if you will. It uses DeepSee, but we've abstracted away a little bit of the architecture of the cubes. You're able to do some overrides and some additional functionality with it, but yeah, it's by default all of your Health Insight uses it. Yep. Well, if nobody has any other questions, thank you for coming, and if you have any additional thoughts, come see me. I'll be here till tomorrow. So, thank you very much.